Our first speaker this morning is Reinhard Tatschl. Reinhard is from AVL in Austria. He is a research and technology manager in the business unit of advanced simulation technologies of AVL, the world's largest independent company for the development, simulation, and testing of powertrain systems, providing complete and integrated development environments, measurement and test systems, as well as state-of-the-art simulation methods. Reinhard graduated in mechanical engineering in 1988 and received his PhD from Graz University of Technology in 1992. He joined AVL in 1991 as a research engineer in the field of computational fluid dynamics, modeling and simulation. From 2000 onwards, Reinhard has been leading the CFD software development team before taking over his current position as the research and technology manager in 2012. A major focus of his current activities is on advancing AVL's simulation methods and tools towards supporting engagement or engineering tasks related to various types of fuel cells and electrolyzers, batteries and e-machines, from concept layout to detailed component development and optimization to systems integration and calibration. Reinhard, over to you. Thank you very much indeed.
Yeah, thank you, Paul, for the kind introduction. Good morning, everybody. From my side, it's my pleasure to have the opportunity to provide you an overview of the low-temperature fuel cell R&D activities at AVL. And let me first start with a bit of information about AVL. So we are the world's largest independent, privately owned company for development of all kinds of powertrain systems, from classical to battery electric, fuel cell electric powertrains. So we have a staff count of around 11,500 people worldwide, and 65% of them being engineers and scientists. We have an export quota of 96% and 1,500 granted patents, and running 45 affiliates over the world. And to give you some idea where we are present, so we have a strong focus naturally in Europe. We are headquartered in Graz in Austria, and actually serving all the markets around. We have strong presence in North America, in Asia, with technical centers and research centers serving our customers. So with our activities, we're addressing a broad range of applications and markets, ranging from passenger cars, two-wheelers and racing, to commercial vehicles, construction equipment and agriculture, to locomotive, marine, and also stationary power plants on a large scale. So we're organized in three different business units. Advanced simulation technologies, where I'm located myself. So we are developing and marketing simulation methods and tools. We have the powertrain engineering division, which provides the engineering services to our clients, and the instrumentation and test systems division. Regarding the fuel cell activities, we have been active for more than 15 years in this area, with all our business units. And so on the advanced simulation technology side, we have developed a multi-physics 3D CFD simulation to provide detailed insights into the transport and conversion processes in all kinds of fuel cells and electrolyzer cells. And besides that, we also offering system simulation tool supporting the engineers in the development of fuel cell systems, and from the concept phase to the detailed component development phase and component integration. The colleagues from the powertrain engineering division are developing fuel cells on cell and stack level, and have a strong focus on the integration so fuel cell system integration, so BOP component selection and sizing and integrating the bits and pieces together to form the entire running system, as well as the integration of the fuel cell system into the entire powertrain in all kinds of vehicles. And the instrumentation and test system division is providing the development platforms required for testing on cell stack system level, and also on the level of system integration into the entire vehicle, including all the measurement and instrumentation devices. So we have recently heavily invested into the fuel cell activities by teaming up with Greenlight Innovation on the testing side to strengthen our portfolio in the cell and stack testing area. Besides that, we have ramped up a team in Canada, in Vancouver, for research and development on cell and stack level, as well as we've ramped up the activities in Germany, focusing on hydrogen storage and infrastructure topics. And last but not least, have strongly expanded our testing facilities and research facilities at the headquarters here in Graz, Austria. So our activities in the last 2 decades have led to a complete portfolio of development methods and tools both on the simulation side and on the testing side, supporting the fuel cell development in all different phases of the development process, and also supporting the development of on component, on subsystem, on system and vehicle integration level. So we do provide the methods and tools to support cell development with respect to performance optimization and minimization of degradation. We do support with our simulation and testing equipment the development optimization of entire fuel cell stacks in order to ensure maximum performance and lifetime. We do provide the tools and methods for virtual system integration and virtual calibration of control functions. And last but not least, also tools and methods for supporting the vehicle integration and optimization of the entire powertrain for real driving missions. Let's have a bit of a deep dive into the simulation applications related to low temperature fuel cells. With our multi-physics 3D CFD solution, we're supporting virtual cell development in different aspects regarding flow field design and membrane electrode assembly components selections. With the CFD simulation providing a detailed insight into the media supply, transport and conversion processes, providing information to the engineers how to optimize geometrical conditions, how to optimize operating parameters to achieving high performance and long lifetime of the cell. We do offer unique features with respect to simulation and handling of liquid water transport and formation, and as well as models for simulation of degradation processes, degradation phenomena related to carbon corrosion and ionomer degradation, providing the information required for the engineer to optimize the geometrics and the material parameters achieve the desired lifetime. Multiphysics CFD is also used for optimization of the media supply and the temperature homogeneity in the entire stack. Also contributing to achieving the performance targets and lifetime targets. And it's also used to derive the requirements for the balance of plant layout and component selection in order to supply the hydrogen and the oxygen to the stack and ensure the proper cooling of the stack by proper dimensioning of the cooling system. And on system level, besides BOP component selection and sizing and detailed component development, there are additional aspects that can be handled by CFD and system simulation, like for instance, compressor layout and matching of the compressor to the specific system in order to ensure maximum overall efficiency. And also cooling system layout in order to ensure proper thermal management of the stack for all different operating conditions can be done on a virtual basis by adopting the different simulation tools today. Well, based on the results and the detailed insight the simulation tools can provide, and in combination with the instrumentation and test systems and test possibilities, it's already possible now to do to cover the entire development from the early concept phase to component design, to component integration, to virtual validation, from the very first idea to start of production in a consistent and reliable way. Well, this so far from my side. Thank you very much for your interest, and I'm handing back over to Paul.
Reinhard, thank you very much indeed. It's an excellent image there of how AVL has grown in the new market. Can you let us know how much of the product portfolio now in AVL is focused on fuel cell technology and that meeting the hydrogen demand in engineering?
Well, there's a very dynamic growth in this area of fuel cell and also electrolyzer cell business. It's not only low temperature fuel cell; it's also high temperature solid oxide fuel cells and electrolyzer technology on different based on different technology. And so we see a very strong demand and interest from the market to go in this direction, and yeah, and we're ready to support.
Given the manufacturing base of AVL, how big a hurdle to the hydrogen market is the lack of electrolyzers and fuel cell manufacturers in Europe?
Well, that's not an easy question to say. However, we are well prepared to supporting and serving the industry and in ramping up the features and capabilities. And so there are initiatives already ongoing where we are involved in, and we're expecting to see growing opportunities in this area.
It's just that in the poll at the start, we asked the audience, how can Europe prosper from the hydrogen revolution? And very few, not all of the audience said, develop the manufacturing base. But do you see the lack of hydrogen manufacturing, especially in fuel cell and electrolyzers, being an impediment for European development?
Well, it's I think a big opportunity for Europe, to position itself in this area, and so that affects or is related to the entire value chain and that starts by research and development, by engineering, and further goes up to the manufacturing and production, and so there's big potential, and there's already a lot of IP available in Europe. That's an excellent basis for further utilization.
Yes. Question from Dr. Bodo Gross in ITSIS in Saarbrücken in Germany is the solid oxide fuel cell SOFC technology developed by AVL? Is it developed in-house?
We are involved in that as AVL, yeah, and with a strong focus on the system integration in the balance of plant development, component collection, sizing, and integration into entire systems.
Excellent. And a question from Diana Laikar in IECE in Macedonia for you, Reinhard. Has the AVL simulation software tool been developed by the company staff, or was it a result of collaboration with academia and research centers?
Well, we do have a long tradition in cooperating with universities and academia on one side, and also in collaborating in joint research projects with industry partners on national level and also on European level, and we do have a considerable track record of successful projects in this area with different consortia and partners.
Thank you. And one final question before we let you go from Matthew Gilsonen. Has AVL looked at biogas fuel cells?
So the fuel cells we are developing or we are involved in are also supporting, besides pure hydrogen, different other types of fuels, and among that is also gas or natural gas or biogas, which where we also support the development of the reforming process in order to being able to utilize natural gas, biogas in the context of fuel cell.
Reinhard, thank you very much indeed for a very informative presentation and for handling those questions. Thank you very much indeed.
Thank you.
Thank you.